So, I will continue with Leelavati in this second lecture on the topic. We continue with some applications of right triangles and what are known as Suchi problem. Then he discusses the construction of a quadrilateral. Some of the earlier confusions seem to be removed. So, for instance, the area of a cyclic quadrilateral was given as, remember, square root of s minus a into s minus b into s minus c into s minus d. So, earlier it was not stated specifically that it is for a cyclic quadrilateral, but Bhaskaracharya tells that it is only for a cyclic quadrilateral and it is not correct for any arbitrary quadrilateral. So, then he will go on with the construction of a quadrilateral. So, essentially apart from only 4 sides is not sufficient, you have to specify one more thing, one more angle or a diagonal. So, then given the 4 sides and one diagonal, how to find the second diagonal, then he continues with the cyclic quadrilaterals. So, then the last this topic also is very important, value of pi, I mean that is the ratio of the circumference and the diameter in a circle, area of a circle, surface area of a sphere and volume of a sphere are discussed. So, a rational right triangle, for instance, suppose you have a side A upright half of a squared by n minus n, then hypotenuse is half of a squared by n plus 1. Of course, it is obviously true because this square plus this square will be equal to this square, but how to get this? So, I mean, where do you start from? So, Ganesha Devagna explains in his famous Buddhi Vilasini commentary. So, suppose the side is A, so then let hypotenuse minus upright be n, okay. I mean take side to be A and the difference between the hypotenuse and the upright is n, and let the upright be x. So, then obviously a squared plus x squared, a is the side, upright is x, x squared plus x squared is hypotenuse, which is now upright plus n. So, that is x plus n whole square. So, x squared plus n squared plus 2xn. So, you immediately get x is equal to half of a squared by n minus n, and hypotenuse is x plus n is equal to half of a squared by n plus n. So, this ratio a squared by n, that is what is. So, essentially you are starting with side A and hypotenuse as n plus the other perpendicular side, you get this. Or given, suppose you are given the hypotenuse and an assumed number, you see here side A and some number is given, here hypotenuse A and assumed number is given, then by the you will find the upright to be 2a n by n squared plus 1 and the side is this a into n squared minus 1 by n squared plus 1. So, these some ways of construction. Okay. So, then the various problems he discusses, some of them have become very famous. Most people who talk about Leelavati talk about this, the so called bamboo problem. Suppose a bamboo of height a is there standing vertically, it is broken at height x and the tip falls to the ground at a distance b from the root of the bamboo. So, what is happening is that there is a big bamboo is there. So, then at some height it is broken, okay, and then this will be the thing. So, that this plus this you see is equal to the original height, right, and this is, yeah, so this is x, so this is a minus x, so this is a and so this is, yeah, b, yeah. So, Vamshagra Moolantara Bhumi Vargo Vamshodritastena Prutak Yutono Vamsho Tadarte Bhavata Kramena Vamshasya Kande Shruti Koti Rupe. Okay. Of course, you can enjoy the poetical beauty also of this Vamsha coming various places, but what it means is the square of the ground intercepted between the root and the tip is divided by the length of the bamboo and the quotient severally added to and subtracted from the bamboo, the halves of the sum and difference will be the two portions of it representing the hypotenuse and the upright. So, essentially he is talking about the situation where, so this is the hypotenuse. So, h plus x is equal to a, right. So, h squared is clearly h squared is b squared plus x squared. So, h squared minus x squared is b squared. So, h minus x is h squared minus x squared by h plus x. So, that is equal to b squared by a, because h squared minus x squared is b squared. So, from Sankramana, so h plus x is a and h minus x is b squared by a. So, from Sankramana, upright is x is equal to half of a minus b squared by a, and hypotenuse h is half of a plus b squared by a. So, this is essentially Ganesha's explanation of the result. So, he gives an example also. If a bamboo measuring 32 cubits and standing upon level ground be broken in one place by the force of wind, and the tip of it meets the ground at 16 cubits, say a mathematician at how many cubits from the root it is broken. Yadi samabhuvi venuho, that the bamboo, danta pani pramano, danta is 32, pani is hasta, cubits. So, danta prani is 32 cubits, pramano, that is the measure, ganaka, pavana vegad ekadeshe sabhagnaha. So, because of this force of the wind, it is broken at some this thing. Bhuvin rupamita haste ishu veva lagnasta dagram, and the tip of it meets the ground at 16 cubits. Kataya katishu mula desha bhagnaha kareshu. So, where is it broken? Okay. So, here it is this is 32. The total height before it got broken, that is 32, and this is 16, b is equal to 16. So, then you can find out x and h, right. Danta is 32, it is 32 teeth. Pani is hasta, so that is the cubit. Pramana, yeah. Danta prani pramana, yeah. So, that will of course satisfy the criteria meter also, so, and sounds nice. So, here x is finally the solution is x is equal to half of a minus b squared by a. So, half of a is 32, b is 16, so b squared is 256 by 32. So, this will be 12, and h is a minus x is 32 minus 12 is 20. Okay. So, this is the solution to the problem. 12, 20, then this is 12. So, total of this is 32, right, 12 plus 20, yeah. Then again you have this famous snake peacock problem in verse 150. Asti sthambatale bilam tadupari krida shikhandi sthitaha sthambo nandakarochita trigunita stamba pramanantare दुष्ट्वाहिं बिलमावज्रन्तमपतत् तिर्यक्ष तस्योपरि क्षिप्रं ब्रूहि तयोः बिलात् कथमिते साम्येन गत्योर्युतिः. So, a snake's soul is at the foot of a pillar 9 cubits high, and a peacock is perched on its summit. Seeing a snake at the distance of thrice the pillar gliding towards his hole, he pounces obliquely upon him. Say quickly at how many cubits from the snake's hole they meet, both proceeding an equal distance. Okay. So, here is the problem. See here, this is some stamba pillar. So, upon that some peacock is there. So, this snake is here, the bila, that is this hole is here. So, snake is proceeding towards this. So, and it says that the peacock is proceeding to, it is flying to moving to catch the snake. So, it is said that both of them are meet at some point, such that the distance that they have travelled is equal, that is, they move at the same speed. Okay. It is also given that this total AC, that this is 3 times this height, so 27. So, we should know this x. So, x 27 x. So, AB is 9 qubits, AC is 27. So, this is x, let us say. So, CD is 27 x minus x, so this is equal to BD. So, BD squared minus AD squared is equal to AB squared. So, 27 minus x whole squared minus x squared is 9 squared. So, if you solve this, you will get x is equal to 12. So, snake and peacock meet at distance 12 from the hole. Okay. Of course, this will lend itself a good dramatization also. There is some CD made on Leelavati, you know. So, there they demonstrate all these, you know, some of these problems are demonstrated, you know. So, snake is coming, you know, the music, you know, snake is coming and peacock is this thing. So, nice. In fact, earlier Chandralekha from Chennai also had done a play, this thing on, you know, dance drama based on Leelavati. I have not seen that. It has inspired so many people in so many ways. Then again, this is also a famous problem called the lotus problem. Sage sakhe padmatan majjana sthana madhyam bhuja koti karnantaram padma drushyam nalaha koti retan mitam syadhyatombo vadaivam samaniya paniya manam. So, earlier you see the lotus is there, this is the root, so this is the base, and because again of the force of the wind, so lotus will get submerged. Okay. So, this will become the diagonal, this will become the, you know, AC will become AD, AC is equal to AD. Okay. So, then this is given, this BD is given. So, where is it getting submerged? Okay, B, that is given. So, then you have to find out the depth. Okay. So, lotus as seen above water is the difference between the hypotenuse and the upright. The stack is the upright. For the depth of water is measured by it. Say what the depth of the water is. Okay. So this is the, I had already. So, essentially you have this a plus d whole squared is equal to this thing d squared plus b squared. So, d is equal to b squared minus a squared by 2a, and a is one span. Suppose a is one span, half qubit, then b is 2 qubits is given to be, so depth is 15 by 4. So, it is simple application of the right angle theorem. So, then again it comes to the ape problem. Ruksha dhasta shatoshtaya chata yuge vapyam kapihi koshagat, etc. So, from a tree 100 cubits high, an ape descended and went to a pond 200 cubits distant, while another ape vaulting to some height off the tree proceeded with a velocity diagonally to the same spot. If the space travelled by them be equal, tell me quickly, learned man, the height of the leap, if thou have diligently studied calculation. Okay. So, that is essentially you have this situation. So, this is some tree, okay, and then there is a pond. So, tree this is 100 and this is pond is there some 200. Okay. So, then one monkey is descending and reaching this pond here. So, another monkey is leaping, okay, and then goes diagonally. Okay. So, then you have to find this leap. So, this is the leap. Okay. So, again solution is given in actually an earlier verse. Sometimes it happens, it gives the this is solution first and then gives the method. So, the height of the tree multiplied by its distance from the pond is divided by twice the height of the tree added to the space between tree and pond. The quotient will be the measure of the leap. Okay. So, Vinigna तालोचित संयुतं यत् सरोन्तरं तेन विभाजितायाः तालोचिते स्थाल सरोन्तरग्निया उड्डीयमानं खलु लभ्यते तत्. Uddiya is Udan, leap. So essentially he is calculating this x, this leap is x. So this is A is equal to this height of the tree, and B is the distance between the tree and the pond, right. So clearly x is, and one sees that actually x is equal to, so it is essentially same as the two ascetics problem in Brahmasputa Siddhanta, okay. The same thing, we had discussed this earlier. So only this, some numbers have been changed and the ascetics have been replaced by monkeys. So you will get the solution as AB by 2A plus B, okay, where A is the this thing height and B is the distance between the these B. So this height is a leap, so that is given as, one can check that 2AB by A plus B. Then in that case one can check that A plus x whole squared plus B squared is that the diagonal, A plus x whole squared plus B squared, okay. So that is the square root of that, is the diagonal of the hypotenuse, okay. So x plus hypotenuse must be equal to A plus B. So x plus hypotenuse, x plus square root of x, A plus x whole squared plus B squared, that is A plus B, right. So this is H is so x plus h is equal to A plus B. So A plus x whole squared plus B squared. So if you take it to this side and square it, you get essentially this. So then he discusses the some segments and perpendicular, they are also considered as important. Suppose you have two bamboos, AB and CD are the bamboos, and heights are AB is equal to A small a and CD is equal to B. Suppose the distance between them is D, AC is D. So now top of each bamboo is joined by string to the bottom of the other, you see. So this is the situation, and P is equal to EF is a perpendicular from the intersection of the strings at E to the base AC at F, and find, you have to find P and the segments AF is equal to x1 and FC is equal to x2. So that is what you have to find. So one can again, you have to find, do the similar triangles. EF by FC is equal to AB by AC. So like that, various similar triangles you have to do. So finally you get P is equal to AB by A plus B. So this perpendicular, you see, this is just given by AB by A plus B. So interesting, it does not depend upon D. This perpendicular does not depend upon D, and of course once you know the perpendicular, one can find these segments, okay. So x1 and x2 are given, yeah. So this kind of a, so for example is given bamboos 15 and 10, suppose distance is 5, then what is the perpendicular? Perpendicular will be 6 and this is 3 and 2. So just similar triangles are used. So this is, in fact this type of problems will come later in the quadrilaterals and all that, various kinds of very complicated kind of the segments and these perpendiculars will be there. So it will be quite instructive. Even in Brahmasputa Siddhanta it is there. It is, so that continues, and he gives a lot more detail of various segments. It will be good to understand the thing thoroughly, and all these geometry configurations etc. will be clear. That seems to be the reason why they are doing this. So then he continues with these triangles and quadrilaterals. So verse 161 it is stated, in any rectilinear figure one side cannot be greater than the sum of the other sides. So, this is what kind of a theorem which had not been stated earlier. I mean, I am sure even Bhaskaravan would have realized, being a very intelligent mathematician, astronomer, Bhaskara, Varner, Mahavira, they all would have realized, they had not stated it. So, he had stated it explicitly. Then given the segments and the perpendicular in terms of the two sides and the third side, that is the usual standard thing, abhada, right, segments and the perpendicular lamba. So, they are all stated, and then area is half base into altitude. So, that is also given. Then he considers a case of a triangle with an obtuse angle to illustrate a point, in a triangle wherein the sides measure 10 and 17 and the base 9, tell me promptly, expert mathematician, the segments, perpendicular and the area. Dasha sapcha dasha pramau bhujau tribuje yatra navapramahi abade vada lambakam tata ganitam ganita tatra me. So, what is happening is that here there is a triangle like this. So, this is 17 and so this is 10, okay, and this is 9, and one can see that it will be an obtuse angle here, So, you have to find the segments and the perpendicular. So, one can do it here. The quotient is, see, b squared minus c squared by 2a. You see, a, if you write it as this b and c and this is a. So, remember, in the segment calculation you get b squared minus c squared by 2a, it comes, and that has to be added and subtracted from a. So, b squared minus c squared by 2a is 21. This cannot be subtracted from the base, wherefore the base is subtracted from it. Anena bhuruna nasyat asmadeva bhurapanita. So, he says that so one of the segment is negative, that is to say in the contrary direction. Runagata abadha digvaiparithyena ityartha. So, the two segments actually are found to be 15 and 6, and the perpendicular is 8 and the area is so. So, this is the two segments. So, this will be 15 and this will be 6. So, here you see, normally earlier we had considered this kind of a thing in acute angle, you see. So, these are the segments and the sum of the segments is the base, right. So, here you have to take 15 minus 6 you have to take, So, he is explaining that, dig vaiparityaha, it is going in an opposite direction. So, see, because here one segment is this tip to this and this tip to this, here this into this, the other is actually this into this from here to here. Runagata abhada, you see, so negative. So, this is a negative segment which is shown by the dotted line. Then he discusses the construction of a quadrilateral and its area. Sarvadayo yutidalam chatusstitam bahubhi virahitincha taddathehe moolam asputha phalam prajayate spashtameya uditam tribahuke. This is important what he is saying. Half the sum of all the sides is set down in 4 places and the sides are severally subtracted, that is S is a semi-perimeter, right, semi-perimeter. So, area is this, the square root of the product is area. So, he is very clearly saying inexact for quadrilateral, moolam, the moolam is the root, asputa is sputa is clear or correct, is given for even longitude of a planet. Sputa is true longitude, asputa is inaccurate, okay. Asputa phalam prajayate, spashtameva uditam tribahuke, if there are 3 tries, three-sided figure like a triangle, of course that is exact. Of course there you have to put one of them to be 0, right, D or something must be 0. So then he goes on to discuss this, because he says, why is it indeterminate? चतुर्भुजस्य नियतौ हि कर्णौ कथम तथा अस्मिन् नियतं फलं स्यात्. Since the diagonals of a quadrilateral indeterminate, how should the area be in this case be determinate? So that is what he is saying. प्रसादितो तच्छ्रवणो यदो द्वौ स्वकल्पितत्वाद् सिरत्रनस्तः, etc. he is saying. So that is, the diagonals found assumed by the ancient do not answer in another case. With the same there are same sides, there are other diagonals, and the area of the quadrilateral is accordingly manifold. So that is what he is saying is, for in a quadrilateral, opposite angles being made to approach contract their diagonal as they advance inwards, while the other angles receding outwards lengthen the diagonal. Therefore, it is said that with the same side there are other diagonals. Okay. So how can a person neither specifying one of the perpendicular nor either of the diagonals as the rest, or how can he demand a determinate area while they are indefinite? Okay. Such a questioner is a blundering devil. Still more so is he who answers the question, for he considers not the indefinite nature of the lines in a quadrilateral. This thing, you see. So in of course Sanskrit it looks stronger, Sapruchakaha pishacho va ganaka nitaram tatha yona veti chaturbaho khetasya aniyatam stitim. So what he is saying to say is the following. Okay. See, suppose it is a quadrilateral. Suppose you are just given 4 sides. He is telling, just by giving the 4 sides, can you determine the area? That is the question he is saying, asking. See, suppose this is your quadrilateral. Okay. So one quadrilateral you have got by A, B, C, D kind of a thing. But he is saying that with the same side you can construct the other quadrilaterals with the same sides. Okay. See, for instance, these can come closer. These can come closer. So let us say A, okay, and then D, C kind of a thing. So this is also A, B, C, D. Okay. So here the diagonal is longer, and this diagonal is shorter, and so this angle is becoming increasing, and these angles are decreasing. That is what he is trying to say. Opposite angles being made to approach. Opposite angles being made to approach are contracting the diagonals. So this diagonal is shorter than the other diagonal, while the other angle receiving outwards lengthen the diagonal. Okay. So now this will be lengthening. So with the same sides we get different quadrilaterals, various quadrilaterals with the same sides.
So he's just talking about compressing or
Yes. So therefore it is said with the same side there are other diagonals. Okay, given the sides, the diagonals are not specified. So how can a person neither specifying one of the perpendicular nor either of the diagonals as the rest? Okay. So or how can he demand a determinate area while they are indefinite? So it is not determined. Okay, because there are several. Okay, or several quadrilaterals are there. So how can it demand a determinate area? So it is not specified completely. Okay. So he is the person who is, if he states that result so that is he is taking him to task, to say the least. He is taking him to task, and then of course says suppose somebody is asked that question, what is the area? This is the sides, what is the area? So that kind of a questioner is a blundering devil, and somebody who tries to answer that, he is even more of a blundering devil. That is what he is saying. Because Chumma without knowing, without actually knowing the problem in the this thing question. So, he is trying to give an answer, gassing. So, these he is saying. So, essentially the A, B, these are the sides. So, we have to specify to specify D, for instance this diagonal, or to specify this D, you see. So, if we just given the side, this location of the points is not see, in triangle that is not true. If you give the 3 sides, the triangle is completely fixed, but not in the quadrilateral. So, to specify this D, either you should give you should either give one the diagonal, or you should give the perpendicular, or give this angle. So, apart from the sides, you have to do one more thing. So, that is, then he goes on, suppose you are given 4 sides in the diagonal, how to find out the second diagonal. Okay, so that is what is next problem. इष्टोत्र कर्णः प्रथमं प्रकल्प्य स्त्यस्रे तु कर्णोभयतः स्थिते ये कर्णतयोः क्षमामितरौ च बाहु प्रकल्प्य लंबावबधे प्रसाद्ये आबादयोः एकैक कपुत्स्थयोः यत् स्याद् अंतरं ये तत् कृति संयुतस्य लंबैक्यवर्गस्य पदं द्वितीयः कर्णो भवेत् सर्वचतुर्भुजेषु भुजेषु, or in all these quadrilaterals. Okay. So, this is the, so what do you do? First, a diagonal is assumed, one diagonal. In the triangle situated on each side of the diagonal is made the base of each, and the other sides are given. So, the perpendiculars and segments must be found. Then the square of the difference of the 2 segments on the same side being added to the square of the sum of the perpendiculars. The square root of the sum of those squares will be the second diagonal in all tetragons or quadrilateral. So, what he is trying to say is the following, you see. So, you are suppose you are given all the 4 sides and this diagonal. So, given the diagonal, you see, you drop perpendicular on this from A and C. Okay. So, then you see this DH prime and H prime B in this triangle. So, DH prime and H prime B are the segments are abada, and P2 that is the lambaka, right, lamba. Similarly, with the same base in this triangle, you see BCD, P1 is the perpendicular, and now DH and HB they are the segments. Okay. So, these are the, so you get segments and perpendicular different corresponding to which triangle you are considering. So, let us say DH prime is D1D, I call it as that, and DH prime B is D1A. So, these segments associated with P2, sorry, D1C. So, that is DH and HB, HB is D1B. So, D1C and D1B they are the segments associated with this P1, and similarly DH prime is equal to D1D and H prime B is equal to D1A. So, they are segments associated with P2. So, now he is saying extend AH prime to G, and he is not saying, I mean I am getting the result. So, you would extend that such that the site is P1 and drop a perpendicular from here to here. So, then your CG will be essentially D1C minus D1D. So, DH, so on the same side the segments associated with 2 different triangles, right, D1C minus D1D. So, this will be this, which is this, and the second diagonal will be, you see this will be, you see this is P2, this is P2 and this is P1. So, this AG will be P1 plus P2, sum of the perpendiculars, you have to square that, plus you square the difference between some segments associated with different triangles. So, D1C, so which is this minus this. So, square these things, add them and take the square root of the second diagonal. So, for instance, he gives an example where D is 68. So, this D is 68, then A is 75, B is 40, sorry, these are the sides 68, 75, 51 and 40. and this diagonal is 77. Suppose this diagonal is 77. So, then it is only a matter of details. You can find the segments and all that, and finally, you get the second diagonal to be 85. So, you get the point. You see, you are given A, B, C, D and this diagonal, then you can get the other diagonal AC using this method. Okay. So, then it goes on to the construction of a cyclic quadrilateral. So, same method as given in Brahma-Sputa Siddhanta is given. So, you start with two right angle triangles B1 A1 C1 B2 A2 C2, these are two right angle triangles. So, then construct 4 triangles from that. Okay. So, this multiplied by A2, this triangle increased by a factor of A2, okay, and then increased by a factor of B2, and similarly this increased by a factor of A1, this increased by a factor of B1. So, triangles and place them like this. Okay. So, this is cyclic quadrilateral which has been discussed earlier. So, now very important thing now is that you can construct another cyclic quadrilateral. That is what he is saying, that had not been discussed by Brahmagupta or Mahavira. So, what he is saying is that essentially you exchange these two triangles. Okay. So, here these, see in this, of course, in this construction the diagonals are intersecting perpendicularly, they will be perpendicular to each other. So, now what he is saying is that take this side to be this, interchange. So, essentially you get this kind of a thing, and so this will be the same A1 A2 B1 B2. Earlier they proceed, they joined together and they constituted one diagonal. Here they have been separated, right, and this will be A2 B1 and this will be A1 B2. So, you can find the second diagonal, and the second diagonal will be C1 C2, one can show that this is the second diagonal. CD, okay. AC will continue to be A1 B2 plus A2 B1, and the second diagonal will be C1 C2. We may also note that in this construction the diagonal BD is the diameter of the circle circumscribing the quadrilateral. So, Bhaskara discussed various ingenious methods to derive various quantities associated with quadrilateral and using similar triangles. So, we do not have too much time. So, now we will go to circle, the discussion of circle in Bhaskara. So, he has many new things to say regarding circles compared to what the earlier persons, mathematicians, Indian mathematicians said. He says that व्यासे भनन्दाग्निहते विभक्ते कपाण सूर्यैः परिधिः सुसूक्ष्मः द्वाविंशतिग्ने विहते च शैलैः स्थूलोऽथवा स्यात् व्यवहारयोग्यः. When the diameter of a circle is multiplied by 3927 and divided by 1250, the quotient is the near circumference, or multiplied by 22 and divided by 7, it is the gross circumference. So, Dvavimshati is 22 and Shaila is of course 7, Shaila is a mountain or this thing, so that is 7. So, Dvavimshatigne vihate ta Shailahi, that is the approximate this thing. So, then Bha is 27, which stands for the 27 nakshatras or the 27 fold division of the zodiac. So, Nanda is 9 and Agni is 3. So, Bhanandagni is 3927. So, the circumference divided by diameter is 3927 by 1250, which is almost the same as the Aryabhatan value 3.1416, and the rough value is 22 by 7. Okay. In his Buddhivilasini, Ganesha Daivagna explains the value 3927 by 1250 for pi. So, it is just Bhaskara has stated this. Okay. So, you start with a hexagon, okay, inscribed hexagon inside a circle. So, you can take for the very approximate value, you take the circumference of the hexagon to be the circumference of the circle. So, that is a very crude value, because circumference of the hexagon will be 6 times the hexagon side, which is r. So, circumference will be 6r, so which is fairly crude, or 3d. 3 times the diameter. So now he says go to the dodecagon. Buddhavilasini he is explaining these things. So that is construct a polygon with sides 12 like this, you know. So this is the side of the dodecagon, okay, and then suppose this is h and this is side of that, so this is r by 2. So essentially so first you started with hexagon, so it is not good enough. So then you are doing the dodecagon. So each this thing is made into 2 kind of a thing. So this is the center of the circle. So this is your h. So this is your r, radius of the circle, okay, and this is also r. So this is the side of the dodecagon. A12, I write it like that, and this is clearly r by 2, right? With the hexagon side also is r, so half of that is r by 2. So then clearly, so in this triangle r minus h whole squared plus r by 2 whole squared is equal to r squared, right? So r minus h whole squared plus r by 2 whole squared is equal to r squared. So you get h is equal to r minus root 3 by 2 into r. So that is that mana or shara or arrow, right? So that is r minus root 3 by 2 r, okay, and so a12 square, clearly this is equal to h squared plus this. So h we have found, square root of that. So you get a12 is d is equal to, we find, you know, using a calculator I get this, but Ganesha gives the value d into square root of 673 by 100. So circumference is approximately, if you use a dodecagon, it will be 12 into square root of 673 by 100. This will be the value of pi if you start from a dodecagon. Somewhat better than, this will be more than, much better than 3. So in this manner he says, Buddhavilasini, if you have polygon of 384 sides, so 384 is 12 into 32 is 12 into 2 to the power of 5, okay. So this you have to keep on dividing 5 times over, you see, and get a polygon of higher and higher number of sides. So then the Buddhavilasini, he says that it is square root of 98683 by 100, you know, that is what this thing is given. So which is equal to 3927 by 1250. One can show that, then this will be, because this into this will be 39, one can show that 392673, which is 392700. So at least he has given the procedure correctly. So and this is the better. So then as the last topic in this second lecture on the Lilavati, it's a very important thing, area of a circle, surface area and volume of a sphere in verse 203. Vrutta kshetre paridhi gunita vyasapadaha phalam yat kshunnam vaidaihi upari paritah kandukasyeva jalam golasyevam tadapicha phalam prushtajam vyasanignam shadbir bhaktam bhavati niyatam golagarbhe dhanakyam. So in a circle, a quarter of the diameter multiplied by the circumference is the area, that multiplied by 4 is the net all around the ball. This content kanduka ball, this content of the surface of the sphere multiplied by diameter and divided by 6 is a precise solid termed cubic content within the sphere. So what he is saying is area of a circle, he starts with that, the circumference into diameter by 4, so it's pi d squared by 4. I mean they do not use pi, as I have already mentioned, for modern notation I am writing, what they say is this, and this is correct. Surface area of a sphere is circumference into diameter into pi d squared into 4 pi r squared, which is this, and volume of a sphere is circumference into diameter squared by 6, which will come out to be 4 by 3. So they are all exact results, okay. So here he surface of a area of a sphere, see what he is saying is, so this is a 3-dimensional figure, you know, a 3-dimensional figure. So he says it is a ball kind of a thing, so in which you cover it with a thread, kanduka, jala, you see. So, that will be the area. So, that is what he is saying, and volume of a sphere is this. Now, in Leelavati none of these are derived or they are explained in detail. Ganesha's derivation of the area of a circle in Buddhi Vilasini, so that we can take up. So, what he is saying is, which I had indicated, see, you make it into two semicircles, and this semicircle you write it like this, see this triangle you write it like this. Of course, in a very large number means this will almost look like a straight line, this arc. So, this is the straight line, this one, So, all these triangles you put it like this, one after the other. Second triangle is this, not this, all the lower thing, and here also you take this, you see, this one is this, and next one is this, you put it like that, okay. So, when you combine them, you combine these two things. So, this will be you will get a rectangle, okay. So, all these are all vacant here. See, in the first thing these are all vacant, these are all triangles and these are all vacant upper things, there is this triangle with vertex feeling, vertex downwards, okay. Similarly, here these are the vacant things, triangle with vertex going upwards. So, now you club them together, so they will exactly fit in and you will become a rectangle, and the side of the rectangle is diameter, and the smaller side, the bigger side will be the circumference naturally, right, because you are adding all these things basically, you are adding these, okay, and here, and adding all these things here. So, essentially you will get a rectangle, and this will be the height of that rectangle is only diameter by 2, and this will be circumference, okay. This will be half the circumference, this will be the half the circumference, rectangle with sides, circumference by 2 and diameter by 2 radius, right. So, area is clearly 1 by 4 into circumference into diameter. So, that is what he gets. Then surface area of a sphere, so that is a little tricky. So, he discusses this in Siddhanta Shiromani Goladhyaya, and in the Vasana, that is the commentary, he has himself written a commentary. So, there he discusses that. So, what he does is divide the hemisphere into 24 strips, okay. With this arc bit, each of them is 90 degrees by 24, and the area of the strip is, in our language, see, this is the radius is r sin theta, the radius will be 2 pi r sin theta, that will be the circumference into this side r delta theta, you see. So, area of the strip is this, and r delta theta is r into, as I told you, delta theta is 90 degrees by 24, in radians I am writing as pi by 2 into 24, and the theta i's, these are pi by 2 into 24 into I going from 1 to 24, you are dividing into 24 divisions, that is already written. So, now you have to essentially sum these area of the hemisphere, you have to sum these things, right. So, this is at the ith level, this will be r sin theta is the radius, okay. So, you have to sum over all these strips. So, this is the thing, and r delta theta. So, Bhaskara carries out the sum explicitly using the 24 r sin values from the table and reports the measure of the hemisphere to be 2 pi r square, and what he says of course is actually this whole thing will be half the product of the circumference and the diameter. And Yukti Bhasha proves that the, okay, sorry. So, what he gets will not be exactly this, but when he does this sums with using the values he has taken, it will be very close to that, okay. So, then he will take it to be, it will be very close to what you get is 3 4 something, what you get, the number will be close to 3438 squared. So, that is r, as we had discussed earlier many times, Trijya r 3438 squared. So, very correctly guesses that what you are getting, if you are doing these things more accurately, then finally you should get something r squared you should get. So, he says that, and finally he states it as half the product of the circumference and the diameter. Whereas Yukti Bhasha, it will be done later, proves that the area of the hemisphere is 2 pi r squared. It essentially does the integration, sin theta d theta, sin theta is there. So, they know how to infinite series for sin theta, and also they know that if you the differential of sin is cos and the differential of cos is sin. So, they exactly get this result. There is no summation, summation is assumed, and finally you get what is recognized is very clearly that the derivative of sin theta is cos. That of course will be explained later. So, you get the correct result Bhaskara, but the method is slight deficiency which will be covered up in Yukti Bhasha. And volume of the cone also is very interesting, volume of the sphere. So, you can take it as various cones, as if it is made up of various cones. Suppose you consider some cone with delta A as the area, and volume of the cone bit, you see that is tapering to this thing, and we know that when there is a volume which is tapering, the volume is 1/3 the base area into height, right. This has been told, and the base area is delta A and the height is r only, radius, that is all. So, 1/3 delta A into A, and the volume of the sphere is 1/3. So, when you sum over all these things, you have to take all these things into account. R will be the same, you have to sum over the area elements. So, no matter how you have divided it, if you take the sum, it will be surface area of the sphere which has been derived earlier. So, this will be area of a sphere, 1/3 of area of a sphere into r. So, which is 1/3 into 4 pi r cube, that is how it is seen. So, this is how he is, it is a very important thing, because I do not think they had discussed the area of a sphere and volume of sphere exactly. They had area of a circle was given earlier, even Mahavira had given that, and Brahmagupta also would have known that, but the area of a sphere and the volume, so this is the first time it is explicitly spelled out. And again the relation among chord, Shara and diameter, so these things are standard things, we had discussed this earlier. The references are given here. Thank you. Yeah.
I found that concept very interesting, in which they have described the volume of the surface area of a surface area of a sphere as Kanduka Jala.
Kanduka Jala, yeah.
So, I mean, I'm just reflecting on it. So, actually, they are measuring a surface area in terms of a length with a negligible
length, but then what happens is that length. So what will happen is the area element only will come, length will disappear actually. So, he is saying you cover the surface with a net kind of a thing, that is what he is trying to say. But he will not he will not use this thing, but it is a calculus kind of a thing. He is doing a summation.
Yes.
He is doing explicitly the summation, that is what you do. Suppose you want to find the integral of something in a computer, you do this, you do various elements and then sum it over. So, that is basically it is done, but only there seems to be some slight this thing, you could have done it better, you could have done better, and the exact thing is.
It's a gross value.
Yeah, no, value is exact, but what is, the method is slightly this thing, short of the perfection. Yeah, but Yukti Bhasha he gives the correct thing, because what is essentially involved is integral sign will be cos, and then cos 0 to pi by 2, so that will be give 1. So, that he has not, he knew that. Bhaskara, of course, in various places in astronomy and other, he does give the result that the differential of sine is cos, that is used everywhere, many places in his Siddhanta Chudamani, but somehow he has not used this, he has not put it here.